Hello, Professor Zawolo again. Today we're going to be going over another section of the West African Examination Council Senior Secondary School Examination Mathematics for Liberian Schools. Today we're going to be going over another section of the number and numeration section, section E, which is on logarithms. Today we're going to focus on two key objectives on learning how to compare between indices and logarithms and how to apply the basic rules of logarithm to simplify and evaluate logarithmic expressions. So, to be able to do that, let's have a little introduction to log. So, logarithm is the inverse of indices. That is, for example, when we have y is equal to bx, it's the same as saying log base b of y is equal to x. That means when you raise this b to the power of x, you get y. So, it's like the inverse of indices. So, here are some basic properties I'm sure you already know. You've been introduced to these properties in your classrooms. They are very important properties. Maybe you just need to copy them, summarize them, and be able to recall and retain this information. That log base b of b is equal to 1. That means because b to the first power is just b, b to the 0 power is 1, so this property holds. Now, this has to do with multiplying two logs. So, or when you have a sum of logs of the same base, you can put them together as a product. So you can work this way there, or you can work this way to the other end. And another very important property is this one, which we really use to solve a lot of problems, especially involving logarithmic and equations involving indices. So it says log base b of m to the power of b. It's the same as saying the product of p log of base b of m. So, okay, also, here's a property that we can use. If we say that look, b to the x is equal to b to the y, the only way this is possible is when x and y are equal, because b and b are already equal. So that's the only way this is going to be possible. Okay? Very important rule to remember. Sounds simple, but it's not. Now, the first problem we have here is given the expression below, express y in terms of x. So that means we must basically solve for y in terms of x here. So let's see how we can do this problem. Let's see how we can do solve for y in terms of x. So let's see first thing. Let's see how we can do some basic things here. One, we have log 10 of y is equal to, well, since we have base 10, I could write this as log 10, because log base 10 of 10 is just 1. Plus 3 log base 10 of what? X. So then let's see something. I'll do log base 10 of y is equal to, now I can join these by addition. The first thing before I do that join thing, let me apply this to the power of that. 10 plus what? Log base 10 of x what? Cube. Where did that come from? Let's go back right here. Right away here, this law is what I'm applying. Okay? Correct, good. So now, I can join this again if I go back to the law that I have over there. So I have log base 10 y is equal to, so this can be joined by the product. So I will have base 10 of what? 10 what? X what? Cube. Sorry. Cube. So look and see what we have. So if this is the case, if log base 10 of y is equal to that, then obviously we can clearly see here that for this to be equal, if this is equal, then y must just be equal to what? 10 what? X cubed. Correct? Y must just be equal to 10x cubed. So I think one of the basic idea was how to write one using this. And this is going to come back. This is a very important thing that you're going to be able to do. Say for example, this was 2. We are written as log base 10 of what? 100. So that's a very important skill. So again, we're going to be using the property here, because one thing we can see here is that from here, let me take this point right here. So log 10, well, I can rewrite it as 2 what? Cubed. Right? That's one thing. What is 2 cubed? 2 cubed is the same as 1. Now, I can also use the power properties of log to rewrite this as 3 log 10 of what? 2. Now, I know what this is. This is given to me right over here. So to be able to find that value, to compute log 10 of base 8, I can write this as being equal to 3 log base 10 of 2. Then I'll write 3, and because from here, I have this result, log base 10 of 2, to be 0.301. Then all I have to do is just multiply this. It becomes 3 times 1 is 3, 3 times 0 is 0, 3 times 3 is 9.903. Again, all it comes down to understanding and applying those basic rules that we have. Right? Let's move on to the next problem. Look at it carefully. Let's see if we can move on to the next problem. So this is problem number 2. All right. So one of the things, so this is number 3, is taken from the West African Examination Council, WAEC, 2009 examination. So there are many approaches to do this problem. One of the approaches could be, if you look at all of these numbers, 4, 8, 16, and 32, there are some powers of 2. For example, 4 here is 2 to the second power. 8 here is 2 to the third power. Now, we can convert everything in that way to do it, but better still, just leave it here like this and see how we can do it. So one change I want to make is going to be right here. So let's proceed. We're going to write this as log 4 plus log 8 to the power of 2 minus log of 16, all divided by log of 32. Now, I can join these two by product and with this one by division. So let me take care of this. So what I'm going to have here on top will be log 4 times 8 squared is 64. So I'm going to have 4 times 64 divided by 16 using, and at the bottom here I'm going to have log of what? 32. Now let's see how we divide this. 64 divided by 16 is 4. So what I have on top now will be log, so this is going to be 4 times 4 is 16. I have log 16 over log of what? 32. Now, 16 and 32 are powers of, I can write them using powers of 2. So let's turn to the next, let's go to the next slide and see how we do it. Let's do that. Log of 16 over log of 32. So I have log of 16 over log of 32. I know there's a temptation here to divide. You cannot do 16 divided by 32. That will be wrong. So what you can do here is to write this as log. 16 is like 2 to the power of what? 4. And 32 is the same as 2 to the power of what? 5. So I can use the power property to rewrite this as 4 log of what? 2. And rewrite this as what? 5 log of what? 2. So the log 2 will cancel and our answer will just be what? 4 over what? 5. It's kind of simple, but it requires a lot of thinking to get to this point. Now there are other approaches. We would have converted them to power base of 2 earlier and then proceed from there. So one of the things we can do is that 2 and 2/5. Well, let's do this. Let's see how we do this. So let's do log base 10, 2.25. There's a plus sign, so we can join it with this by multiplication. But before we do that, let's rewrite this part as log base 10, 2 to the what? 4th power. Minus log of 10, 0.6 squared. So let's see what we can do here. Well, so these two are going to be joined by addition with that with division. So we can write this as log base 10. Now 2/5 is the same as 9 over 4, and I will show that to you. This is 2.25. That's the same as 2. 0.25 is the same as 1 over 4. 4 times 2 is 8 plus 1, that's 9/4. So I'm going to write this as 9/4 times 2 to the 4th is going to be what? 16. So, and then we're going to be dividing this by 0.5 0.6 what? Squared. So let's do the division here. 4 into 16 is 4. 4 times 9 is 36. What we have will be log base 10 of 36 divided by 0.6 squared. It's going to be 0.36. If we divide that, we're going to have, if we divide this, it's like moving the decimal point one place. We're going to have, okay, we can say move it 2 places. So if I move it 2 places here, I'm going to have log base 10. If I move this 2 places, I'm going to have 3600. If I move this 2 places, I'm going to have 36 here. When I divide this, I'm going to have log base 10. 360 divided by 36 is going to be, just cancel this 0, 36 will be 1, so that's 100. And so what's the result of this? 2, because 10 to the second power gives you 100. So again, very, very much involved with a lot of the rules here. You got to put into place and use them. But very simple. Take some time. That's why I'm slowing down so that you can have a chance to see this on the screen and watch it carefully and see the processes that we went through. Now, here's some of the cases wherein you have to do a little bit of thinking. So you see here that the base here is what? 10. We normally call this common log. We don't normally write it with the base of 10. For some reason in the WAEC they're using base 10. That's fine. That's a convention they are using. So well, what I have to think is that how can I write 2 using a base of 10? Well, 2 is the same as saying log 10 of 100. Why? Because 10 squared is equal to 100. So instead of writing 2, I can put this. So I can write this 2 as what? Log 10 of 100. So minus, and then I'm going to also use this rule here and write this as 2 what? Cubed. So 2 cubed is 8. So what I'm going to have here will be log 10 100 minus log is 10 of what? 8. So we can take this to, yeah, we can do this right here. So we can do this log is 10. So we're going to have what? 100 over what? 8. Subtraction converted into division. And when we simplify this, we're going to have log divide this by 4, you're going to get 25. Divide this by 4, you're going to have 2. And that will be basically our answers for that. So I think we'll have one or two more problems to do. Let's get on to that. Again, take some time and look at it carefully. I'm going to slow down so that you watch the screen and see what's happening here. Take some time, patiently look and observe and see what's happening. You can stop the video. That's one of the things about the work we are doing. We are doing this so that you can use it as your own tutor. Now, this is a base here. If I can rewrite this as using this thing, which I can do, because 49 is the same as 7 squared, log base 7 of what? 2. Another thing I can do is I can push this, sorry, I wrote this the wrong way. And it'll be because I'm jumping this thing so fast, so maybe that's why I wrote the wrong thing. So let's go back. This problem was taken from WAEC, Liberia 2006. It was problem number 44. So one of the first things I would do is to write 49 as 7 squared. So then I have log base 7 what? 2. So another thing I can do is to move this 2 up there. So what I would have would be 7 log. So I can rewrite this using the rule, if you go back to the first slide, as log base 7 of log 7 2 squared. So again, by rule, whenever we have this case, then our result is just going to be equal to this. Remember that rule. A to the log of, say, B of what, M would just be equal to what? M. Alright? I think that was one of the rules of the first show slide, the second slide that we gave you. A log A of A, sorry, it should be the same A right here, of M will be equal to M. That's the rule we're applying it. So basically, with this and this, so our result would just be this, which gives us what? 4. 2 squared is 4, so that's going to be our answer. So again, I think this is the last problem we have to do. Again, I'm going to pause the screen so that you look over it carefully Again, this has been a production of Field, the Foundation for Equity and Excellence in Education in Liberia, a foundation created and established by Liberians dedicated to providing quality content education for all Liberian students. We are on the web at www.fieldliberia.org. You can send us your feedback at fieldliberia2015@gmail.com. Please subscribe to our YouTube channel, like us on Facebook, follow us on Twitter, and take some time, register on our website to begin using our pilot software that will give you the opportunity to practice some of these problems.